Okay, let's differentiate the following. So we have two cases. So the first case, y is equal to 3x cubed minus 5x to the power negative 2 plus 9x. We're just going to be employing the power rule here. So when I'm using the power rule, I'm going to use Leibniz's notation to show that we are looking for the derivative function, dy over dx. And I did a derivative of each term. So the derivative of 3x cubed, so I'm using the derivative modifier here according to Leibniz's notation, minus 5, the derivative of x to the power negative 2, plus the derivative of 9x. Okay, and if I look at the derivative of 3x cubed, this is going to give me 9x squared minus 5 times negative 2, x to the power negative 3, plus 9. Okay, what I want to do now is I want to simplify this guy out. So I have 9x squared plus 10x to the power negative 3 plus 9. And usually what we want to do when we're doing the derivative, we want to use positive exponents. So dy over dx is going to give us 9x squared plus 10 over x cubed plus 9. Okay, so this is our derivative function. Now let's take a look at the next question. For question 8, we can see that this is a radical. I want to change the radical as an exponent, right? So the exponent version of this is y is equal to 2x plus 6 to the power 1/3. Okay, and I'm using the rule x to the power a over b, which is basically x becomes the radicand. A, which is the numerator, is the power on the radicand. B is the index on that radical. Okay, so I'm using that to express this as 2x plus 6 to the power 1/3. Okay, so in this case, if I do the derivative, I'm going to be employing the chain rule. So if I use the chain rule, I'm going to first employ the power rule. So 1/3, 2x plus 6, subtract by 1 to the power, so minus 2 over 3. Then I'm going to do the derivative of the inside. So the derivative of the inside here is 2x plus 6. Right, and then this is going to give me, if I simplify it, dy over dx, our derivative function, is equal to 1/3 times 2x plus 6 to the power negative 2 over 3 times derivative of the inside, which is 2. Now, what you want to do here is you want to use positive exponents. I can multiply the 2 by the 1/3. So this is 2 over 3. Because we have a negative here, this implies that we have a root function that is found on the denominator. So we have 2x plus 6, and because the denominator of the power here is a 3, this is a cube root, and the radicand should be squared. Okay, so we can write our derivative function dy over dx as this. Okay, find the derivative function. So if we look at this function, y is equal to x plus 5 times 7x minus 2. In this case, we have to actually use product rule. So if we're using product rule, the derivative function dy over dx is equal to, I'm going to do the derivative of the left hand factor. So derivative of x plus 5 times 7x minus 2 plus the derivative of the right hand factor, 7x minus 2 times x plus 5. I'm going to simplify this. So dy over dx is equal to the derivative of x plus 5 here is 1 times the rightward factor 7x minus 2 plus derivative of 7x minus 2 is 7 times x plus 5. In this case, you get 7x minus 2 plus, I'm going to expand this out, plus 7x plus 35. I'm going to group the like terms together. So if I group the like terms together, I get 7x plus 7x minus 2 plus 35, which is 14x plus 33. Okay, so this is basically your derivative. Okay, let's find the derivative function of f of x. So we want to find f prime of x. Okay, so in order to do that, what I'm going to do here is I'm going to use the quotient rule because it does look like a rational expression where f of x looks like g of x over h of x. Okay, so if I'm using the quotient rule, f prime of x is equal to the derivative of the numerator, g prime of x, times the denominator h of x, minus the derivative of the denominator, h prime of x, times the numerator, g of x. And this is going to be over h of x, the denominator, squared. Okay, so if I'm finding the derivative here, if I'm using this template, f prime of x is equal to the derivative of 3x minus 1 times x plus 5 minus the derivative of x plus 5 times 3x minus 1, and this is going to be over x plus 5 squared on our denominator. So I'm looking at the derivative. If I clean this up a little bit, the derivative of 3x minus 1 is 3 times x plus 5 minus the derivative of x plus 5 here is 1 times 3x minus 1. I'm just going to work on simplifying the numerator first, and then I'm going to combine the denominator. So if I expand this guy out, this is 3x plus 15 minus 3x plus 1. In this case, excuse me, 3x minus 3 is 0, and then you get 15 plus 1 is 16. Okay, so this is after I've simplified the numerator, and if I combine this together, so this is the numerator, if I combine this together, f prime of x is equal to 16 over x plus 5 squared. Okay, so that is the derivative function. Okay, let's find the derivative function of y is equal to 4x squared minus 5x to the power 4. Just by looking at this equation, you can notice that we have to use chain rule. So if I'm using chain rule, if I'm finding the derivative of y with respect to x, the first thing I want to do is I want to do the derivative of the outside, so employ power rule. So I'm going to do 4 times 4x squared minus 5x to the power of 3, and then I'm going to do the derivative of the inside. If you're doing the derivative of the inside, you get 4x squared minus 5x. Recall that we use chain rule if f of x is equal to g of x to the power of n. Right, so f prime of x, or dy over dx, is basically n times g of x n minus 1, right? So in this case, and then we have to do the derivative of the inside, so g prime of x, right? So that's basically chain rule. So in this case, if I simplify this out, the derivative y with respect to x is equal to 4 times 4x squared minus 5x cubed times the derivative of this portion here, which is 8x minus 5. So if you wanted to simplify this, I'm just going to write it out here. dy over dx here is equal to 4 times 8x minus 5 times 4x squared minus 5x cubed. Okay, and you can just leave your answer like this if you wanted to expand this out. You can also do that as well, but it's really the same thing. Like if I do expand this out, you get 32x minus 20 times 4x squared minus 5x cubed. So it really means the same thing. Okay, and that's your derivative function. So you can either use that or that. Alright, the position function of a particle is given by s of t is equal to t cubed minus 12t squared plus 45t plus 3, where time t is in seconds, distance s is in meters, and t is greater or equal to 0. Find the velocity of the particle when the acceleration is 0. Okay, so we know that our acceleration function, a of t, is the second derivative of our position function. So it's s double prime of t, or the second derivative of the position function s of t. Now I'm going to find the first derivative function of s of t, and this is our velocity function. So velocity function is the first derivative, which is basically d dt of t cubed minus 12t squared plus 45t plus 3. And I'm just going to employ the power rule here to solve for this. So this is going to give me 3t squared minus 24t plus 45. Okay, so this is our velocity function. To find our acceleration function, I'm going to do the derivative one more time. So a of t here is the first derivative of the velocity function, which is basically 6t minus 24. Okay, so that's your acceleration function. We want to find the velocity of the particle when the acceleration is 0. Well, if we want to find the velocity when the acceleration is 0, let's first figure out the time it takes to make the acceleration 0. Right, so I'm going to let a of t equals 0. If a of t is equal to 0, then we have 6t minus 24 is equal to 0. I'm going to move the 24 to the other side, so 6t is equal to 24. If I want to solve for t, I'm going to divide by 6 to both sides. T is equal to 4. So at 4 seconds, the acceleration of the particle is 0. When the acceleration of a particle is 0, that means the velocity is constant. Right? We call this uniform motion. Now what you want to do is you want to find the velocity of the particle at that point. So I'm going to take my velocity function, v of t is equal to 3t squared minus 24t plus 45. And I'm going to plug in v of 4. Okay, so if I do v of 4, because t is equal to 4, we're basically going to get 3 times 4 squared minus 24 times 4 plus 45. And if I calculate this, it's going to give me -3 meters per second. Okay, so we know that velocity, the units for velocity is meters per second. The units for the position function s of t is in meters, and the units for acceleration is meters per second squared. So it's important to also understand the units. And we have a negative velocity, so whatever direction was positive, the particle is moving right, and let's say that's the positive direction. If the velocity is negative, then the particle is going to be moving to the left. So it's arbitrary depending on what the reference point is. So that is the velocity of the particle. All right, the following graph illustrates the position versus time of a moving object. Use the graph to answer the following questions. In what interval is the object moving towards the origin? Well, if we're looking at object that's moving towards the origin, we're looking at a negative slope. And specifically, we're going to be assessing the slope of the secant between 2 points, right? So you notice that the interval between C and D have a negative slope. So I'm going to draw the secant in blue. And there's also another secant. I'm just going to use a different color here. But there's also another secant with a negative slope between D and E. So both cases, the object is moving towards the origin, right? Because it's going back in direction. So it basically would have a negative direction. If we say that the position that is moving away from the origin is positive, the position moving towards the origin is negative. Okay, so this is going to be our positive direction for the time being. Okay, so positive directions are going to be shown by positive secant. So the interval in which the object is moving towards the origin could basically be between C, D, and E, right? So
you can join the blocks here.
Thanks. Okay, so when we're considering the interval, we have to look at the independent variables. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I want to look at the interval between C, which is, it looks like 7.5, to E, which is 16. Okay, so I'm going to assume that time is in seconds and position is in meters. Okay, so in the interval that the object is moving towards the origin, the interval is going to be between 7.5 seconds. So t belongs to 7.5 seconds and 16 seconds. Okay, so in that case, we're basically looking in between the interval, because at the point of C, we're changing directions, and we also will change directions at point E. So I'm just looking in between the interval. So I have greater than 7.5 seconds, less than 16 seconds. Part B, in what interval is the object's velocity positive? So the interval is where the object's velocity is positive, and I'm going to show you guys this using a secant, a positively sloping secant. So you can notice here that these two secants, right, call it slope 1, slope 2, right, slope 3. Okay, so in this case, the interval is where the object velocity is positive. It looks like, well, the first interval here, t belongs to 1 and 1 all the way to 7.5. Sorry, 0 all the way to 7.5, because it's going to encompass from point A to point C. Okay, as well as from 16 all the way to, and then this point here is going to be 17, 18, 19, 20. So 16 seconds all the way to, looks like 21 seconds. Okay, so 16 seconds all the way to 21 seconds. So we want to say both of these intervals are inclusive. So 16, excuse me, 16, 21, so union 16 and 21 seconds. So between the time of 0 and 7.5 seconds and 16 and 21 seconds. When does the object change direction? Well, we can see a change in direction at point C as well as point E. So when t is equal to 7.5 seconds, it'll change directions from going away from the origin going back towards the origin. Okay, so going from the positive direction back to the negative direction. And then in point E at 16 seconds, we can see that we change direction from D to E, which is going towards the origin, to away from the origin at E to F. Okay, describe the motion at the interval E and F. Because we have a constant slope of the position time graph, this indicates that our velocity is constant. Okay, so velocity is constant. The velocity function will have a constant slope as a result, right? A constant change as a result, right? So the velocity is going to be constant. This basically identifies the uniform motion. Okay, so this is important to understand. There is no acceleration as a result. So the velocity time graph at this case would just be a pure constant depending on what the slope of this line is, right? So if the slope was, for instance, 2 of this line, then the velocity time graph would be 2 at that point, okay? All right, the cost function for producing x units of a product is c of x is equal to negative 0.003x squared plus 4.2x plus 3,000. The revenue function is r of x is equal to 138x minus 0.15x squared. Determine the marginal profit for the sale of 100 units of the product. Okay, so this is an economic application of calculus. And in this case, before we can actually determine the marginal profit, we need to first define that profit. The profit function is the revenue function minus the cost function, right? Profit is revenue minus cost. Now, marginal profit is the profit that is basically being created per unit of good that is produced and sold, right? So in this case, our profit function is going to be equal to our revenue function. So the profit function here is the revenue function minus cost function, so it's 138x minus 0.15x squared minus c of x is negative 0.003x squared plus 4.2x plus 3,000. And what I'm going to do here is I'm going to simplify it. So p of x here is 138x minus 0.15x squared plus 0.003x squared minus 4.2x minus 3,000. I'm going to collect the like terms. So p of x here is equal to 138x minus 4.2x minus 0.15 plus 0.003, which is 0.147x squared minus 3,000. Okay, so basically that gives us a function 133.8x minus 0.147x squared minus 3,000. Okay, so now what we want to do here is we want to find the marginal profit function, and in order to find the marginal profit function, I want to find the derivative of my profit function. So the marginal profit function p prime of x is equal to the derivative of 133.8x minus 0.147x squared minus 3,000. I'm going to be employing the power rule. So this is 133.8 minus 0.147 times 2, which is 0.294x. Okay, so this is my marginal profit function. And we're not done yet because we want to find the marginal profit for the sale of 100 units of the product, right? P prime of x is equal, I'm going to plug in 100 units. P prime of 100 is equal to 133.8 minus 0.294 times 100. And in this case, 133.8 subtracted by 0.294 times 100 is going to give us 104.4. Okay, so this is basically our marginal profit at selling 100 units. So it's $104.4, right? As long as the marginal profit function is greater than 0, this tells us that our marginal revenue function, which is the revenue that is being generated per unit of good produced and sold, is greater than our marginal cost function, which tells us the cost of each good that is being produced. As long as the revenue function is greater than the marginal cost function, then this tells us that the company is profiting and that they should continue to produce. And usually companies or firms will keep producing until their marginal profit function is equal to 0. The following function describes the motion of an arrow shot upwards. The height h is in meters after time t in seconds. H of t is equal to negative 5t squared plus 40t plus 2. Find the maximum height reached by the arrow. What is the impact velocity of the arrow when it hits the ground? Okay, so to find the maximum height of the arrow, what we want to do is when the velocity of the arrow hits 0, we basically have a maximum height. Okay, and we can figure out if we set the velocity function to 0 and we solve for time, then we can basically find t max, right? So this value here would be the maximum, the time it takes to get to the maximum height. Okay, so time it takes to get to the maximum height. So right now we have the position function. H of t is just position on the y-axis because we're basically moving up or down. And if we want to find a velocity function, it's the first derivative of h of t. So we're doing h prime of t, which is equal to the derivative with respect to the rate of change of time of negative 5t squared plus 40t plus 2. And in this case, the velocity function, the derivative of negative 5t squared is negative 10t plus the derivative of 40t is 40. And we want to let the velocity function equal 0. And we're doing this because when the velocity function is 0, the object is temporarily at rest, and it also enters its maximum height. We want to solve for the time it takes to get to the maximum height, so I'm going to solve this equation. Negative 10t plus 40 is equal to 0. I'm going to move the 40 to the other side. Negative 10t is equal to negative 40. I'm going to solve for t, so I'm going to divide this by negative 10. I'm going to do the same thing to the right side. And in this case, t is equal to 4 seconds. Okay, so at 4 seconds, the object will reach is maximum height, but we want to figure out what the maximum height is that it reaches, right? So what we need to do, we plug this back into our height function. So if we plug it into our height function, we're doing h of 4 is equal to negative 5 times 4 squared plus 40 times 4 plus 2. And if I calculate this, you get negative 5 times 16 plus 160 plus 2, and this gives me 82 meters. Okay, so h of 4 is 82, and that means that the maximum height occurs at 4 seconds, and the maximum height is 82 meters. Okay, so we know that the maximum height is 82 meters. What is the impact velocity of the arrow when it hits the ground? Okay, so if we're looking at when the arrow hits the ground, I'm just going to change colors so we can look at the next question. Question B, right? Well, we need to figure out the time it takes for the object to hit the ground. We do have the velocity function, so after we find the time, we're going to plug it into this function. So if we want to find the time it takes to hit the ground, I'm going to let h of t equals 0, right? That's the height when the object is at the ground. And we get negative 5t squared plus 40t plus 2 is equal to 0, right? I want to solve for t. For this case, you can actually just use the quadratic formula, right? So t is equal to negative b plus minus b squared minus 4ac over 2a, right? So in this case, the values of t that I would have gotten here by plugging into this equation are negative 40 plus minus b squared is 40 squared minus 4 times ac, so 4 times negative 5 times 2 over 2 times negative 5. Okay, so if you punch this out, you're going to get two values, which are, so t is equal to negative 0.04969 seconds, as well as 8.0496. Because t has to be greater or equal to 0, we can't include this value, so I'm just going to be looking at the 8.0496. I'm going to round that to 8.05 seconds. And if you want to find, so this is the time it takes for the arrow to hit the ground. So if you want to find the velocity of how fast the arrow hits the ground, the impact velocity, I'm going to plug this into the velocity function. So you're doing v of 8.05 is equal to negative 10, 8.05 plus 40, which is equal to and this is going to give us negative 40.5 meters per second. Okay, so this is your impact velocity and occurs at 8.05 seconds, right? And the negative just implies that the object of the arrow, the direction of the arrow is moving downwards, right? So if a positive sign implies that the object is moving up, negative sign would just mean that it's going down. Okay, so the impact velocity here is negative 40.5 meters per second, or you can just say 40.5 meters per second. All right, let's determine the equation of the tangent to y is equal to negative x over x plus 1 squared at x is equal to negative 2. So if we want to find the equation of the tangent is, well, we know that tangent is a line, so it should be in the form of y is equal to mx plus b, right? Now, we want to find two things out of this equation. We need to find the slope of the tangent and the y-intercept, right? Now, in order to do this, it would help us to have a point. We know that x is equal to negative 2. I'm going to find the equivalent y value to this point. So if I plug this in, I'm going to call y f of x. So I'm going to do f of negative 2 to find its equivalent y value. So we have negative 2 over negative 2 plus 1 squared, which is 2 over negative 1 squared, which is 2. Okay, so our point here is negative 2 and 2. So this is the point that the tangent is going to hit. Now, in order for us to find the slope of the tangent, we need to find the derivative function, f prime of x, but we're specifically finding the slope of the tangent at x is equal to negative 2. So we're basically finding f prime of negative 2. So f prime of negative 2 just means the slope of the tangent at x is equal to negative 2. So let's find the derivative function. So f prime of x here, we know that f of x is equal to negative x over x plus 1 squared. To find f prime of x, I'm going to be using the quotient rule. So I'm going to do derivative of negative x. Negative x. So derivative of numerator times the denominator, x plus 1 squared, minus the derivative of the denominator times the numerator, negative x. I'm going to put this over to the denominator squared, so x plus 1. If you square x plus 1 squared, you get x plus 1 to the power 4. Okay, if I clean up the numerator a little bit, we get negative 1 times x plus 1 squared minus, you're going to be using the chain rule here, so 2 times x plus 1. Because the derivative of the inside of this is 1, we don't have to write it, times negative x. And if I simplify this, I'm going to factor out an x plus 1 here. So if I factor out an x plus 1, we get negative 1 times x plus 1 times negative 2 times negative x. And this is going to give me x plus 1 times negative x minus 1. So I'm going to expand this guy out. So it's always good to kind of factor this out because it will make our expression more simplified and it's easier to work with. This is x plus 1 times negative x plus 2x, which is x minus 1. Okay, so this is what the numerator looks like. So our derivative function f prime of x should be x plus 1 times x minus 1 over x plus 1 to the power 4. Now at this point, I'm just going to simplify this a little bit. So I'm just going to move it over here. So if I simplify this, I can divide the common factors. This is power 1, this is power 4. So we basically have f prime of x minus 1 over x plus 1 to the power of 3. Okay, so you want to find the slope at this point. So I'm going to do f prime of negative 2. Okay, so you want to find the slope at negative 2. So f prime of negative 2 is negative 2 minus 1 over negative 2 plus 1 cubed, which is negative 3 over negative 1 cubed, which is positive 3. Okay, so f prime of negative 2 is positive 3. So the equation here is y is equal to 3x plus b. Okay, you want to solve for b now, right? We have the slope. If you want to solve for b, I'm going to substitute a point because we know that a tangent only passes through a single point, and any point that passes through a line will satisfy the equation of the line. So we're going to substitute the point negative 2 and 2 because that's the only point that actually passes, that this line will pass through. So if I plug this in, we basically get 2 for y is equal to 3 times negative 2 plus b, and this is going to give us 2 is equal to negative 6 plus b is equal to 8. So therefore, we have b is equal to 8, we have slope is equal to 3, so the equation of the tangent, therefore, is y is equal to 3x plus 8. Okay, so that is the equation of the tangent to the point x is equal to negative 2. Okay, determine the coordinates of the point on the graph f of x is equal to 3x squared minus 7x plus 4, where the tangent line is parallel to the line 5x plus y is equal to 3. Now, we know that when two lines are parallel, the slope of the two lines should be the same. So the slope of the tangent should be equal to the slope of this line. We'll call it m1, right? I'm going to figure out what the slope of this line is by changing it into y is equal to mx plus b form. This is also known as the slope-intercept form. And by doing that, 5x plus y is equal to 3. I'm going to move the 5x to the other side. So y here is equal to 3 minus 5x, right? So the slope here is negative 5. Okay, so we want to find the slope of a tangent that is equal to negative 5. We know that the slope of the tangent is basically the first derivative function. So we want to find the first derivative function of f of x, f prime of x, is equal to negative 5 and we want to solve for the coordinate, all right? So to solve for the coordinate, let's find the derivative function. F prime of x is equal to, so the first derivative function here is the derivative. We're going to be using power rule, so we're going to do the derivative of 3x squared minus 7x plus 4. So this is going to give us 6x minus 7. Okay, so we know that the derivative function is 6x minus 7. This is the slope of the tangent at a single point of x. We want to figure out when the slope of the tangent is equal to negative 5, so I'm going to equate this to negative 5. So we have 6x minus 7 is equal to negative 5. I'm going to move the 7 to the other side. 6x is equal to negative 5 plus 7. 6x is equal to 2. If I want to solve for x, I'm going to divide by 6. X is equal to 1/3. Okay. So we know the point of x where the slope of the tangent will be parallel to this line, 5x plus y is equal to 3. It'll have a slope of negative 5. We want to find its equivalent y value because they did ask us to find the point. So if we want to find the equivalent y value, you're going to plug this into f of x. So our point would be 1/3 and f of 1/3. So I want to figure out what f of 1/3 here is. So f of 1/3 here is basically 3 times 1/3 squared minus 7 times 1/3 plus 4. In this case, you get 3 times 1 over 9 minus 7 over 3 plus 4. This is 3 over 9 minus 7 over 3 plus 4. And in this case, 3 over 9 you can rewrite as 1 over 3. If you divide by 3 to the numerator and denominator, 1 over 3 minus 7 over 3 plus 4, it's 4 over 1, you can multiply it 3, making the lowest common denominator all 3 here. So we get 12 over 3. So f of 1/3 here is equal to negative 6 over 3 plus 12 over 3, which is 6 over 3, which is 2. So f of 1/3 is equal to 2. So therefore, the point where the tangent is parallel to f of x plus y is equal to 3 is the point 1/3 and 2. Okay, so this is the point where the tangent is parallel. Okay, let's indicate whether the statements are true or false. So in the first case, the value of the derivative at a point on a function measures the slope of the tangent to the curve at that function. This is true. We know that the derivative of a point on a function is basically going to be correlated with the instantaneous rate of change of that function. This is also correlated with the slope of the tangent to that function. So here's an example, like if you had a function that kind of looks like this, and you want to find the derivative of this point, let's call it a. So the derivative of this point at a is f prime of a, which is basically the slope of the tangent at this function. And we know the tangent, I'm just going to use a different color to show that tangent is a line that only hits a single point or passes through a single point. Let's take a look at the second question. The acceleration function is found by differentiating the displacement function twice, right? This is true because in this case, we know that if we have a position function or displacement function, if we have s of t, the velocity function is basically s prime of t, right? The acceleration function is basically the second derivative of the position function because it's the first derivative of the velocity function. So this is true. The derivative, so part 3, the derivative of a polynomial is always another polynomial function. This will be true, right? So here, an example of this, you have f of x is equal to 2x cubed minus 4x. This is a cubic function. If you find the derivative of this will become a quadratic function. If you find the derivative of this becomes a linear function. Whoops, right? So you'll get 12x. If you do the derivative of this becomes a constant, which still can be considered a polynomial function. So this is also true. Question, in case 4, the power rule only works with integer exponents. No, this is actually false, because you can have a scenario where x can be to the power of square root 2, and if you do the derivative of x to the power square root 2, right, then you get square root 2. You can still employ the power rule, square root 2 minus 1, right? Now square root 2, this is not a real number, right? So not a real number because of the fact that it's irrational and it will be expressed as a fraction. It can be expressed as a decimal, right? In non-terminating decimal is what I meant, right? So in this case, the power rule can still work for non-integer powers. For question 5, the sign positive or negative of the velocity of an object at a specific time indicates the direction in which the object is moving. This is true, right? So if we say that the velocity if we say east is the positive direction, right, v of x is greater than 0, but then if we're looking at the opposite direction, west, then velocity would be negative. Now, this would be basically vice versa. If west was a positive direction, then east would be the negative direction, right? So the direction is implied by the negative or the positive sign of velocity. Excuse me. In the last question, an object is slowing down when the acceleration of the object is in the opposite direction of its motion. This is true, because in this case, in part 6, if the acceleration and the velocity is the product of the acceleration and velocity is negative, this implies that the acceleration and velocity are in opposite directions, and the object is actually decelerating. That means that it's essentially slowing down. Its velocity is getting smaller, right? And if the acceleration times the velocity function was greater than 0, then that means that the object is accelerating in the same direction that it's moving, and in this case its velocity vectors are increasing, or the object is accelerating. So this is also true.